Hello, my dear students. Today we'll complete our lesson, resistor connection. Last week we have talked about uh, series connection. What does it mean? Resistance connected in series. It means that they are connected in the same bar or the same wire. All of them have the same current intensity, but the potential difference divide the voltage of the battery divided into V1 plus V2 plus V3. But the current intensity passes in all the circuit is the same, it's constant. I total equal I1 equal I2 equal I3 because they have the same track or the same wire. But today we'll complete our lesson in a second type of connection, which are a parallel connection of resistors, parallel connection of resistors. In parallel connection, resistance are connected in branching roots. Okay, they are connected in branching roots, and the current passes in the circuit divided into I1 and I2 and I3. Okay, like the opposite figure, the voltage of the battery is the same. V1 equal V2 equal V3. It has the same potential difference of the battery. If the battery, the two batteries, gives 4 volt, for example, V1 equal 4 volt, V2 equal 4 volt, V3 equal 4 volt. Okay. The potential difference V1 equal what? From Ohm's law in the first lesson, V1 equal I1 times R1, V2 equal I2 times R2, V3 also I3 times R3. Okay, so if we want to make comparison between resistance in series and in parallel, okay, we have to make this table. In series connection, the equivalent resistance increase because this equal the algebraic sum of this resistance. In parallel connection, the total value decrease smaller than the bigger value, okay, or the smallest value. Okay, right. Let's see an example here. We have three resistance. They are connected in parallel connection. Okay, the potential difference of the battery equal 5 volt or 45 volt, and the internal resistance equal 0. Okay, from the opposite circuit, find the equivalent resistance. Equivalent resistance, they are connected in parallel connection. So we will use the law 1 over R equivalent equal 1 over R dash equal 1 divided R1, 1 over 25 plus 1 over 70 plus 1 over 85. Using your calculator, you will get the equivalent resistance, which is equal 15.814 ohm. Okay, so the equivalent resistance in parallel connection smaller than the smaller value or the smallest value of them. Smallest value equal 25 ohm. So the equivalent equal 15.14 is a really smaller than 25. Okay, if you have series resistance, you want to get smaller value, you must connect it in parallel connection. If you want to use the series resistor to get higher value of resistance, you will connect them in series connection. Okay. Right. Second, the current intensity in each resistor. Current intensity in each resistor. Current intensity in I1 and I2 and I3. Firstly, we want to get the total current intensity. Total current intensity equal V divided R dash. V divided what? R dash. Okay. V 45 over 15.14 equals the total current intensity, which is number C. which is the number C. Okay. So we get the equivalent resistance R dash and the total current intensity equal what? 45 divided what? 45 divided 15.40. Okay. The current intensity in each resistor, okay, all of them have the same potential. يعني potential in the first case or the first resistance I1 R1 equal 45. So if you want to get I1 يبقى V divided R 45 over 25 equal 1.8. I2 equal 45 over 70. Okay. طيب I3 equal 45 over 85. If you want to make check up for the result of your total current intensity, you must to add I1 plus I2 plus I3 if it equals the total current intensity, so your calculations will be correct. Okay. Current I equal I1, I2, I3. Okay. Here we have another example. Find the equivalent resistance for the illustrated circuit. We have resistance 5 ohm and 10 ohm, 34, 5. How many number of resistance here? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 resistance. 9 يا شباب 9 resistance. You want to get the equivalent resistance of this total resistance. How can we get the equivalent resistance of this package of resistance? First, you will start from the 3 resistors which have the same track or the same bus or the same current. 3 ohm and 3 ohm and 3 ohm, all of them they are connected in series. So all of this equal what شباب 9 ohm. All of this equal ايه شباب 9 ohm. طيب 9 ohm and 18 ohm are connected in parallel connection. Connected in ايه؟ In parallel connection. Okay. So we must draw resistance like this equal a 9 ohm. So if you want to get the equivalent resistance of these two resistance, 9 and 18 ohm, you will get 9 times 18 divided 27. Equal what شباب؟ Equal 6 ohm. Equal ايه شباب 6 ohm. So the equivalent resistance of these 4 resistance equal ايه 6 ohm. Okay شباب؟ طيب now I have 6 ohm and 4 and 5. Okay. They are connected in series connection. They are connected يا شباب in series connection. Like this. 4 and 6 ohm and 5 ohm. يا شباب؟ طيب 4 plus 6 equal 10 plus 5 equal 15. 15 and 30. 15 and 30 they are connected in parallel connection. 15 and ايه يا شباب and 30. They are connected in a parallel connection. 15 with 30. If you want to get the equivalent resistance of 15 and 30, 15 times 30 over 45 equal 10 ohm. Equal يا شباب 10 ohm. So this resistance will be cancelled. All of them will be cancelled, and they will draw only 9 ohm. Sorry, 10 ohm. 10. Okay. 5 plus 10 plus 10 equal what شباب equal 25 ohm. We have another example here, example number 3. The opposite circuit calculate in the opposite circuit calculate the ratio between the reading of the two voltmeter V1 over V2. V1 over V2. سوري يا شباب هو V2 here V2 R1 and R2 they are connected in parallel connection. R plus R divided A to R. It will equal what شباب R over 2. طيب and equivalent resistance here is R. طيب the current intensity passing the two resistance equal the current intensity passing in the A in the other. Okay. So the ratio between V1 over V2 equal R1 over R2 or R dash 1 over R dash 2. So R over 2 divided R will be what شباب divided R it will equal ايه يا شباب equal R times 1 over R. يا شباب equal the ratio between 1 over V2 equal half value half ايه يا شباب half value. This notes if you have resistance here, okay, to reach another side of the resistance, if you have a wire, the current will pass through the wire. The current will pass through the wire. So this resistance is cancelled. Why? Because you have an electric wire without any resistance or magnetic resistance. You have another track or another bus without resistance or smallest resistance from the first. If we're connecting wire and another node, if a connecting wire of zero resistance exists in the circuit, the two ends of the wire are considered as a one point. This wire, this point X, and this also will be point X. This point Y and this also will be point A, point O. Okay? If you want to reach from point Y to point X, you will pass through the R1 and maybe from R4, sorry, R5. Okay? 1 and 5 from Y to X. This is A without penalty. Or R4, R3, or R4, R2. Okay? Let's solve this example. Calculate the equivalent resistance in this figure. The equivalent resistance of this figure equal when the current passes through the 50 ohm and 20 ohm current have two passes. One with 200 ohm and there is a without any resistance. So this resistance will be ignored or will be cancelled. It doesn't have any electric current to pass through it. Okay, so the current will pass from 50 through 50 and it will divide it into a 20 and 20 ohm. So 20 and 20 will be connected in parallel connection because they have the same points. Point B is the same point of this point of point C. There is no potential difference between them, so they have the same potential. Okay, 20 and 20 will be taken as parallel connection. You will get a 10 ohm 20 parallel connection with 20 huh, equal R divided by 2 huh, equal يا شباب equal 10 ohm half the value of the total resistance. Okay, 10 ohm they are taken as a series with 20. 10 plus 20 equal 30. 30 with 30 equal 15. equal يا شباب 15. طيب يبقى 50 plus 15 this all resistance will equal ايه يا شباب equal 15. 50 plus 15 plus 35 equal what شباب equal 100 equal يا شباب 100. The total current intensity equal V over R dash يبقى 100 divided 100 100 over 100 equal 1 equal يا شباب equal 1 1 يبقى 1 2 1 يا شباب سوري 1 ampere. The total current intensity equal 1 ampere. Okay. Try to solve this example. There is another idea about the connection of resistance, series or parallel or mix between them. Inshallah, next session will complete this ideas inshallah. Okay.